Hey geometry guys, jumping in with another video, hopefully kind of get you caught up. Hopefully you'll understand a little bit more from me. I don't know, maybe not, maybe the other videos are better. But I wanted to check in about some of these and just make you guys another video. So hopefully this helps a little bit. This is 10.4. And so if you'll grab your interactive notebook and get your notes out, get your book, and follow along with us, okay? Okay, so this is a chapter on isometry or isometries, and it's such a fancy definition in your book. Guys, this just means did you translate it and it didn't change its size or its shape. That's it. Okay, yes, they made it very difficult because that's what our book likes to do, right? So isometries, it is some sort of a transformation . Remember, transformation can be a translation, reflection, rotation. It can also be a dilation, which we'll get to on Wednesday, but that's not an isometry. Transformation where size and shape do not change. So guys, if we were in class, I would say, hey, here's a piece of paper, cut out the shape, and you would sit there and you would cut the shape out, and then we would flip it over something. That would be a reflection, as though it were in a mirror, right? We would set it down on our paper. So let's see, reflection. If I gave you a shape and you cut it out and it looked like this, right? And I said, hey, could you set it down on your piece of paper, but have it upside down? And you would say, oh yes, of course I could do that, and you would reflect it and it would be over here. And it did not change its size or shape. You didn't cut the paper anymore. You didn't make the paper smaller. There's no way you could have done that. You couldn't have changed its shape or size by any means. It was just a piece of paper and you moved where it was. Isometry. Okay? A translation is the same thing. I gave you a triangle in this case, and I translated along some vector, which we learned a little bit about, basically which direction did it move. That's really it. It goes up and over, okay? And now pretend mine's the exact same size and shape. There's no way. If you said, here is the piece of paper, I will cut it out and I will move it from this side of my desk to the other side of my desk. You might move it to the right 3, you might move it up 2. Whatever you did, that's the vector. But it doesn't matter. Your piece of paper didn't have scissors taken to it. It's not cut into rubber where you can pull it and stretch it and distort it, okay? It's the same size and the same shape. It's an isometry. And a rotation is the same. So if I were to say, hey, here is a shape, I don't know, let's not do that shape. Let's do a rectangle this time. Here's a rectangle, and here is some point, and I'm going to rotate it around that given point. I could say, here's a piece of paper, cut it out, and you're going to rotate it over here. And you rotated it, but you didn't take scissors to it again. It is the same size. It is the same shape. You did not stretch it, pull it, any of those things. All 3 of these are isometries because their size and their shape did not change. All right? Now, an identity transformation is when you do one of these 3 transformations and somehow you're back to where you started. It's identity. It's back to who it is originally. So if I had this dot and I put another dot on top of it, I don't know if this is going to work, guys. I think it's going to move both of them. Shoot. Okay, well, let's imagine. If I moved it all the way over here and back again and somehow I ended up back exactly where it is, that's an identity transformation. I don't even really have to move it. If it is exactly where it was, it's the identity. It's itself. Okay. Really fancy term for saying nothing happened. Okay. In the end, composition of isometries is where honors guys. You had a couple of these. We had some shape. So here's your triangle, and I said, hey, could you reflect it over this line L? And you said, yes, of course I could. And so you reflected it, and it turned over and it was on this side, and then I said, wow, could you also translate it over this line? I'm sorry, reflected over this line in. And you said, well, why? Yes, I would love to do that for you. And you moved it again over. Okay? You flipped it over back to the original side. Anyway, so that is what a composition of isometries is. You also could say, hey, let me rotate it around this given point. And you would have yet a new shape, and you rotated it around, except it did not change its size or shape, despite the fact that mine did. Let me try to make that a little more accurate. Okay, could rotate. All of those. If you do more than one of these three in a combination, it could be the same thing 3 times, but if you do any of these 3, again, that is what we call a composition of isometries, okay? But if they're all isometries, we know that there is no change to the size or the shape. All right, I am not going to go over those 3 anymore. I know you spent a lot of time on them last week. We're going to talk about 1 or 2 more here, and I'm really not even going to practice this with you much. I want to keep this video short. You guys have other things to get to. You're probably... Raise your hand. Are you over school? I wish I could see your hands being raised. I wish I could be with you and hear what you have to say, but we'll make the best of it. And so I don't want you to have to do school forever here. So I'm going to try to... I feel like these are ones we probably can understand fairly easily by yourselves. If you do not, please come to Math Enrichment. I will do a video with you. I will call you, whatever it needs to be. We'll work on it together and have fun doing it. So if we had, this is yet one more. This is called a glide reflection. You can find this on page 482. Let's say I had a triangle here. This is my pre-image, the original that I started with, and I'm given a vector, goes 4 over, okay? So now my post image, or where I move it to later, has to follow, I guess I should say vector. That just says, hey, move this point here to the end of that. Wherever you start at the beginning of your red vector line, you end it at the other side of the arrow with the vector line, okay? So that just means I'm going to move this guy, and I am going to see if I can do it this way. I'm going to move him along that vector over here, okay? And once I moved him here, I am now going to reflect him over the x-axis, okay? Now, for a glide reflection, the line that you reflected over isn't always going to be an axis. It is just some line that is parallel to the translation vector. So this guy and this guy are parallel. Okay? And you will be told what line that is. All right, so then I can't flip on this program, but however far this is, and however far this is, and however far this is, I'm going to be equally reflected on the other end. Okay? So if those lines are equal, those lines are equal, and those distances are all equal. Okay? And now I'm going to have my new image down here, and it has been reflected. It did not change its size. It did not change its shape. But if this were a piece of paper, you would be seeing the other side of it now because you flipped it over. Okay? So, glide reflection. This is a type of what? Of a composition of isometries, right? You have composed or put together not only a translation, but a reflection with it. It has a unique name called a glide reflection. Why do you need to change the name? I don't know, but it just did. So every isometry can be expressed as a composition of 3 different reflections. You can move them around different ways. You could say that multiple things happened to everything that you've done to it, okay? Part of your homework tonight is going to be identifying what happened to your original shape. You'll see a black shape and then a red shape, and you need to tell me, did it get translated? That means it just got moved. So this here, if I do anything, let me just draw another shape here. If I translate it, I can show you that here. I'm going to move it. I can move it up, down, over, right, left. It doesn't have to be 90-degree angles like this. It could be moved any direction. That is a translation, okay? The rotation I can also do, oh, that is a dilation. Pretend that didn't happen. Okay, a rotation given around a certain point can also be like this. This shape stays the same size. Shape and yet it can be rotated around a given point, and then a reflection. I don't think I can do that, but I won't go the other way. Okay, that's what we aren't supposed to do. That is not an isometry. All right, the reflection is like in a mirror, which I'm not going to draw it again because we are pointing it out right here. Okay, you will need to identify a identity transformation. If the line is exactly on the same, like if there's no red line because it's underneath the black line, then you know it's an identity transformation. It's the same thing that happened. Let's see. So the last thing that we need to talk about is preserving orientation. Okay, so that means which way something is oriented. So let's go back to my triangle here. And I'm going to erase some of this other stuff up here. We don't really need it. If I were to, let's see, actually, let me put some labels on here. We're going to call this A, B, and C. If I were to translate this triangle, does A stay on the top, B stay on the left, and C stay on the right? Yes. So a translation preserves its orientation. The A is always right next on top of there with the B. And I guess a better way to say this would be, let's say I cut out a piece of paper. One side was red and one side was blue. Okay, so if I translate it, do you always see the red side? Yes. If I were to rotate it, do you still see the red side? Yes, you still see the red side. So if you still see the same color, so the same, imagine you had a piece of paper, same side of your paper. You could label them A and B. You could do this. You could get a piece of paper out and cut it into a shape, label one side A, label the other side B, right? If you see the same side of the paper, then you have preserved the orientation. Okay, preserved orientation. Now, if I were to reflect this guy, so I told you the other side of this paper was blue, right? So if I were to flip this guy over, let's say I had a mirror here, I had a line of reflection, and I were to say, okay, equal distance, however far this is going to be same here. I am going to draw my triangle. I took this piece of paper, and this is now my other side of the paper. And the other side of the paper was blue. It got flipped over. Okay, so now A is here. Oops. I'm actually going to write it as though it were flipped. A, B, I think would stay the same except the bigger one would be on the bottom there, and C would look, if you flipped it, it would look like that still, I think. Alright, well, it doesn't matter. Those letters don't have to be flipped. Alright, if this were reflected over, just like I did over here, just like in the mirror, you are now seeing the other side of the paper. Okay? So if you see the other side of the paper, to be blue, you did not preserve orientation. This is actually called a reversed orientation. Okay? There's two ways that you could actually reverse the orientation, right? So this here, this is your translation or your rotation, which I showed you. Here, if you have a reflection, those are our oh, that looks terrible. Let's try that again. If you reflection, okay, if you recognize, we have three that we talked about before, but now we have this fourth one over here, that glide reflection. So if you glide it, no, that didn't change the orientation at all, but if you do the glide reflection, that is a fourth one now. And that is also a way that you can reverse the orientation, okay? So, quick review. If you're on the same side of the paper, you preserved orientation, as in a translation and a rotation. If whatever you did to it reversed it and you flipped it over, now you see the other side of the paper, then it's a reverse orientation, such as in a reflection or a glide reflection. Okay? All right, I hope this helps a little bit. Tomorrow you're going to watch another video about symmetry, and then dilations is when you are changing its size and its shape, and you will have a video for that. So hopefully you guys are feeling okay about this. Check your homework. Shoot me an email. Tell me how you're doing. All right, miss you guys. See you later.